Hi, in this video we're going to be talking about different types of variables. Now in statistics, a variable of course is a characteristic that an individual might have. That characteristic can be categorized based on what sort of possible outcomes there are. So for instance, a variable is said to be qualitative if the outcomes are not numbers, they're not numerical, or at least they're not numbers that make sense. So for instance, social security number, even though it's a number, would be qualitative because I can't think of putting social security orders in number, like my social security number is greater than yours, or let's find the average of our two social security numbers, or find the highest social security number or the lowest. Since those things have no meaning, that's still qualitative, along with things like eye color and hair color and skin color and car color and first letter of your last name and the grade you earned in a class. On the other hand, quantitative variables are variables where the data will come in the form of numbers that make sense as numbers, something where you can talk about one is bigger than the other, or finding the average of these two, or finding the largest or the smallest. The maximum or minimum, of course, are the terms for that. And within quantitative, and this is what we're going to focus on for this little video, there's a simple breakdown into two types of quantitative variables. One type is called discrete, and the other is continuous. Now, the joke, of course, is that a discrete random variable is a variable that can keep a secret or mind its own business. That, of course, is not what discrete means in this context. In fact, these words discrete and continuous, these are terms from mathematics. They're not unique to statistics. And the idea behind them is that if a variable is discrete, it means that the data, the potential outcomes can be listed. So what does that mean? It means that the potential outcomes, all possible outcomes, not actual data from a sample. You can always list actual data that you got from a sample or even from a census. But if you can list all the possible outcomes, here are all the possibilities, dink, 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 on the down the line. Now, it doesn't mean that that list is going to be short. In fact, that list could be infinitely long, but at least you can set up that list and have a pattern. Whereas with continuous random variables, that there is no idea of next. That is that I have this value, and if I were to say, okay, what's the next value? So, for instance, in math, you might have learned about the real numbers, the numbers on the number line. So if I say, hey, I'm going to start with the number 2, what's the next real number? And somebody says 3. But no, 2.5 was in there. You say, okay, so 2.5 is the next number. But no, 2.1 was in there. Okay, maybe that's the next. Nope, 2.01 was in there. Oh, maybe that's the next. No, that's not the next either. 2.000000001 is in there somewhere, and there is no next number. So there is no idea of next if you try to list the possibilities. Now again, this is about the possible outcomes, not about the actual data that you collect. If I actually sampled 5 individuals and got 5 values, of course I can put those in a list. But we're saying I couldn't make a list of all the potential outcomes. To illustrate this a little bit better, I want to do a couple examples of things that could be seen either way. So one example is the height of a building. If you go to a big city, any city, San Francisco, Oakland, New York, Miami, you're going to see some tall buildings. And if you wanted to measure the height of those buildings, if that was your variable, the height of a building, there's a couple ways you could do that. One way to do it would be to count the number of floors in the building. So this is a 3-story building, this is a 1-story building, this is a 25-story building. That's one way to do it. Now that's discrete. I could list all the possible outcomes. 1-story, 2-story, 3-story, 4-story, 5-story. I can make a list. And again, I don't know what the highest number on that list is. Maybe I'm just like it's 1, 2, 3, 4, 5, etc. That's a list. On the other hand, if I were to measure the height of these buildings in feet and inches to measure them, then that would be continuous. Because if I make that measurement, I'm like, okay, this building is 400 feet, 3 inches, 0.001 inches. But is there a next highest possible height? No, I could add a little increment to that. Gee, I could add an extra brick to the top of the building and it would be slightly taller. Whereas with the stories, that was discrete when we were counting the stories, because adding another brick to the top of the building doesn't change the number of stories that the building is tall. Another case where a variable, it depends on how you gather your data, would be shirt size. So for men's button-up shirts, they're sold by the size of the collar. And so they're often sold, if I go to the store, I've got a choice, 14 inch, 14 and a half, 15, 15 and a half, 16, 16 and a half, etc. It goes every half inch. That's discrete. There's nothing in between. I either get 14 or I get 14 and a half. I can't get 14.2. So that's a discrete random variable. On the other hand, if I went to my tailor, okay, I don't have a tailor. If I had a tailor and I went to my tailor and said, make me a custom shirt that fits my neck like a glove, and the tailor pulls out his tape measure and measures around my neck and says, okay, your neck size is 15.23 inches and makes this custom fit shirt. And I say, great, that's wonderful. Wait, could I have the next size up? This tailor says that there is no next size up. I can add more measurement to that, but there is no next size. You can just add a little infinitesimal amount and see, now it's bigger, but it's not the next size. So that's continuous. In fact, in general, if you're measuring things, it's usually continuous. If you're counting things, it's always discrete. Another way to think of it is continuous is like a clock hand moving around an analog clock to measure time. That's continuously moving. Whereas digital things tend to discretize those measurements. Even though we'll still call the variable continuous, if you're measuring it with a digital clock, you can't really say it's just moving. It's like, oh, it went a full second. It went a full second. Another example of something that sort of can be thought of as both is age. If I say, how long, maybe I'm in a science class, a biology class, and I have a culture of bacteria growing in a petri dish, and I say, how long have they been growing? That's continuous, because I want to know days, hours, minutes, seconds, tenths of a second, hundredths of a second. That idea is continuous. On the other hand, if I talk to a person, an adult person, and I say, hey, what's your age? How long have you been alive? That's kind of what that means. What's your age? And yet the data is going to be discrete, because as I get those values, these people are going to tell me, hey, I am 37 years old, or I am 42 years old, or I am 19 years old. They're not going to say I'm 19.37894 years old. It's going to be discrete. Everything's going to be, in this case, a whole number. Now, if you talk to a parent of a young child, maybe they just had a baby, then they might be counting differently, and they might measure it continuously for the first 3 days or so. Like, ooh, yeah, my baby is 2 days, 3 hours, 5 minutes, and a few seconds old. But after a while, they start moving into the world of discrete numbers again. They start saying, well, it's 2 weeks old, 3 weeks old, 4 weeks old. And then they move into months, and then again, you get into years, and that's clearly discrete, as we only give the whole number of years. But if you said how much time has passed, continuous. Okay, I think those are some good examples. Hopefully you find those helpful. That's it for now. Bye, folks.